everyone, I'm teacher Justin, and for today we're going to talk about trigonometric ratios of special angles. In a right triangle, we have two kinds of special right triangle, and they are the isosceles right triangle, the 45-45-90 right triangle, and the 30-60-90 right triangle. And in this right triangle, we have this special angles that are 30, 60, and 45 degree angles. And we will use them in identifying our trigonometric ratios of special angles. So let's prepare our table. So in our table, we have the angle and we have the trigo ratio. Remember the trigo ratio that we have? Sine, cosine, and tangent. Then for our angle, we have the 45 degree angle. Okay? And if we look at our right triangle, and if we get the sine of this 45 degree angle, opposite over hypotenuse, it will be 1 over square root of 2. Or, if we rationalize it, it will be equal to square root of 2 over 2. Okay? For cosine 45 degrees, it is adjacent over hypotenuse, so it will still be the same as square root of 2 over 2. And for tangent 45 degrees, opposite over adjacent, it will be 1 over 1 or equal to 1. Or for the special angle 45 degrees, we have the value of sine 45, cosine 45, and tangent 45. Now, let's move on to our 30-60-90 right triangle and identify the trigo ratio of that special angle. So for a 30-60-90 right triangle, we have two angles here, which is the 30 degree angle and the 60 degree angle. Okay, so let's get the trigo ratio of this special angle, starting with 30 degrees. So the sine 30 degrees is opposite over hypotenuse. So 1 over 2, 1/2. Cosine 30 degrees is adjacent over hypotenuse. Square root of 3 over 2. So that will be the value of cosine 30 degrees. Okay, and then tangent 30 degrees, opposite over adjacent, that will give us 1 over square root of 3 or square root of 3 over 3 if we rationalize it. So this will be the value of our special angle for 30 degrees. Sine 30, cosine 30, and tangent 30 degrees. Now let's proceed to 60 degrees. Let's get sine 60 degrees. So opposite over hypotenuse. So that will give us square root of 3 over 2. And then cosine 60 degrees is 1/2. And then tangent 60 degrees is square root of 3. And that will be our special angles for these trigo ratios. Alright. Okay, let's solve for the value of x of this right triangle. So, given that this is a 30-60-90 right triangle, let's solve this using the special angles. Okay? So, first thing that we need to do is for us to identify the angle. We have 30 degrees. Then, let's identify our given side. So, we have the hypotenuse, and we're looking for the opposite side. Now, based on our sides that are present in our right triangle, we can use SOHCAHTOA to identify what trigo ratio we're going to use. So, since we're given the opposite side and the hypotenuse, we're going to use sine 30 degrees. Now, sine 30 degrees is equivalent to opposite over hypotenuse. Then, let's substitute our opposite side and our hypotenuse. That will give us x over 12. Now, looking at sine 30 degrees, we have a value for sine 30 degrees, and that is equal to 1/2. So, we will substitute and replace sine 30 degrees by 1/2. That is equal to x over 12. Now, let's solve for the value of x by multiplying both sides by 12, isolating the variable x, giving us 12 divided by 2 is equal to x. Then simplifying that will give us the value of x, that is 6. So our value of x is equal to 6 units. Alright, ta-da! Okay, let's solve for the value of x of this right triangle. So first thing that we need to do is to identify our angle. So in this right triangle, our angle is 30 degrees. And then, let's identify the given side. So the given side is the opposite side. and we're looking for the hypotenuse. So looking at our given, using SOHCAHTOA, let's identify what trig ratio are we going to use to formulate our equation. So since we're given the opposite side and the hypotenuse, we're going to use sine 30 degrees. So we know that sine 30 degrees is equivalent to opposite over hypotenuse. Let's substitute our opposite side and our hypotenuse in our equation, giving us sine 30 degrees is equal to 18 over x. Okay, so now we know that sine 30 degrees is equivalent to 1/2. We will replace sine 30 degrees by 1/2 and equate it to 18 over x. Now let's solve for the value of x. Then let's apply cross multiplication to remove all the denominators, giving us x is equal to 2 times 18. Then let's multiply 2 and 18. That will give us the value of x, that is equal to 36 units. And that will be our final answer. Ta-da! Alright. Okay, let's have this example and solve for the value of x of this right triangle. So, the first thing that we need to do is to identify our given angle. So, we're given 45 degrees. And after getting the angle, let's identify the given side. So, in this triangle, we're given the opposite side and we're looking for the hypotenuse. Now, using our SOHCAHTOA, let's identify the trig ratio that we're going to use for this right triangle. So, knowing that we're given the opposite side and the hypotenuse, we're going to use sine 45 degrees. And it is equal to opposite over hypotenuse. Now, let's substitute our given, giving us sine 45 degrees is equal to 6 over x. Now, we know that sine 45 degrees is equivalent to square root of 2 over 2. So, we will replace it by square root of 2 over 2. And equate it with 6 over x. Now, let's solve for the value of x by applying cross multiplication. So, we cross multiply, giving us x square root of 2 is equal to 2 times 6. So, let's multiply. So, x square root of 2 will be equal to 12. Now, let's divide both sides by square root of 2 to isolate our variable x. So, that will give us x is equal to 12 over square root of 2. So, since we're not allowed to have a radical symbol in our denominator, we will have to rationalize our denominator by multiplying both numerator and denominator by the square root of 2. So, simplifying this, that will give us 12 square root of 2 all over 2. Now, 12 and 2 can be simplified because 12 and 2 are divisible by 2. So, 12 divided by 2 will be 6. And that will give us the value of x, which is 6 square root of 2 units. And that will be our final answer. Ta-da! Alright. Okay, let's solve for the value of x of this right triangle. So, first thing that we need to do is to identify our given angle. So, we're given the 45 degree angle. Then, let's identify our given sides. So, we have the hypotenuse and we're looking for the adjacent side. Now, using our SOHCAHTOA, let's identify which trig ratio are we going to use. So, since we're given the adjacent side and the hypotenuse, we're going to use cosine 45 degrees. And knowing that cosine 45 degrees is equivalent to adjacent over hypotenuse. Now, let's substitute their given. That will give us cosine 45 degrees is equal to x over 20. Now, cosine 45 degrees is equivalent to square root of 2 over 2. So, we will replace cosine 45 degrees by square root of 2 over 2. And that will give us our equation. Now, let's solve for the value of x by multiplying both sides by 20 to isolate the variable x, giving us the equation x is equal to 20 square root of 2 all over 2. Now, since 20 and 2 is divisible by 2, we can divide it, giving us our final answer, which is the equivalent value of x is 10 square root of 2. And that is our final answer. Ta-da! Okay, let's have another example. So, for example, we're going to solve for the value of x of this right triangle. So, first thing that we need to do is for us to identify our given angle. So, our given angle is 45 degrees. Then, let's identify our given side. So, we have the hypotenuse, and we're looking for the value of the adjacent side. So, using SOHCAHTOA, let's identify our given side. We're given the adjacent, and we are given the hypotenuse. So, we will use cosine 45 degrees as our trigo ratio. And cosine is equal to adjacent over hypotenuse. Let's substitute our given. That will give us cosine 45 degrees is equal to x over 7. Now, looking at our table, cosine 45 degrees is equivalent to square root of 2 over 2. So, let's replace cosine 45 degrees by square root of 2 over 2. And it is equal to x over 7. Then, let's multiply both sides by 7 to isolate the variable x. And that will give us 7 square root of 2 all over 2 is equal to x. So, since we cannot simplify that, that will give us x is equal to 7 square root of 2 all over 2. And that will be our final answer. Alright, ta-da! Okay, let's have another example. Let's solve for the value of x of this right triangle. So, first thing that we need to do is for us to identify our angle. So, in this case, it is 45 degrees. Then, let's identify our given side. So, we're given the hypotenuse and we're looking for the opposite side. Now, using SOHCAHTOA, let's identify which trigo ratio are we going to use. So, since we're given opposite and hypotenuse, we're going to use sine 45 degrees. And it is equal to opposite over hypotenuse. Let's substitute our opposite and hypotenuse. That will give us sine 45 degrees is equal to x all over 4 square root of 6. Now, let's look at our table. Sine 45 degrees is equivalent to square root of 2 over 2. So, let's replace sine 45 degrees by square root of 2 over 2. And that is equal to x over 4 square root of 6. Let's multiply both sides by 4 square root of 6 so that we can isolate our variable. Okay, that will give us x is equal to 4 square root of 6 times 2 all over 2. So, let's multiply 6 and 2. That will give us square root of 12. Now, square root of 12 has a perfect square factor that is equivalent to 4 times 3. Let's get the square root of 4. That will give us 2. And square root of 3, it will remain square root of 3. So, let's simplify this by dividing 2 and 2. And that will give us the value of x that is equal to 4 square root of 3. And that will be our final answer. Ta-da! Alright. And that is it. If you like this video, give it a thumbs up. If you have comments, questions, recommendations, suggestions for my next video, please leave them in our comment section below. Share this video and subscribe. And for more videos like this, you can go to my channel, Teacher Justin. And that is it for today. Again, I'm Teacher Justin. Goodbye, God bless, and stay safe. See you on my next video. Peace.